Hey there, Stephen Barter here. How are you doing on this great day? Me? Well, I'm feeling somewhat fired up because today's lesson is another one of my favourite topics. It's a topic that brings many young players undone and makes superstars from those in the know. We are entering the zone of control and the ability to make credible decisions based on factual information. We're going to put a red line through second guessing and put you in the driver's seat. So I'm fired up, I'm also a little bit excited, and I can't wait to get you in the driver's seat as we take control of variables today in ProMold Lesson 6. Okay, so let's get straight into it. In any process, there are variables and there are non-variables. Some are obvious and some are well hidden in the process and also in the engineering. And some are sneakily controlled by people who just can't seem to help themselves with itchy fingers. They just need to get involved. One way I like to look at EBM is much like playing snooker. You always need to be thinking about the next shot, because every move you make will have a positive and negative impact on the process. And that includes the people, of course, the process, and the engineering. Three topics that need to be synced all day and every day. And that's why we need to understand what variables and non-variables actually mean. So here I have just a couple of quick definitions. But let's move on. So let's talk about non-variables first. The key point to remember here is a non-variable is a fixed component that does not change at all unless it physically breaks down or is intentionally changed. When troubleshooting, it is easy to forget this and make corrections against non-variables. This will lead to more problems in the process, and so it is very important to recognize the non-variable is working properly. However, it must not be altered as part of a corrective action. A non-variable can only be changed by design to suit a new process or as a result of an investigation that leads you to an improved standard. Now, variables, on the other hand, a variable is something that can change from time to time. In reality, there are very few variables other than ambient weather conditions, atmospheric pressure, and moisture can play a part in Paris stability, or a build-up of contaminants in the process, for example wax build-up in an extrusion die, or on a blow mold itself. This can change some of the operating conditions, or the results of those operating conditions. Variables in most cases can be measured, and this makes controlling them easier and allows for quick reference checks when troubleshooting. Identify the variables in the process, and then make a number against them so that the information can be recorded in an operating data log for future reference. How do you put a number against them? Well, I like to use a pressure gauge, a rule, or even a transducer with a digital readout, or any other means of taking a reliable, accurate measure and then recording the information on your data sheet. Most importantly, when verifying a change to a non-variable, this must be done under controlled conditions, taking into account all factors in the process. Remember the snooker table example that I used? You've got to be thinking about your next shot. Updating the setup data with changes to non-variables, because that's what was run in the last setting you have, may actually set you up for trouble in the future. Your setup data needs to capture every variable and non-variable as accurately as possible. If you are not improving stability or quality, then question why the change is necessary. Long-term stability and controls for your inputs will bring its rewards in greater productivity. I guarantee that. A final alternative to variables is to convert, let's say we convert a variable to a non-variable. And this is one of my favorite habits. This in many cases is quite easy and is the best alternative to remove the risk of a change. Adjustable bolts can be measured and made into a bar of fixed length. It can become a change part as part of your mold set. A pneumatic flow control valve can be replaced with a fixed size orifice, so there is no adjustment. And these parts can also become part of your mold setup. So let's think about some examples of what we've just talked about. So an extruder position, for example, it doesn't change, nor does the wall thickness controller. It doesn't change either. However, the parison may change when the extruder die is dirty, or you have a faulty thermocouple, or changes in weather. The temptation is to adjust the extruder position or wall thickness controller. You must resist this temptation. Clean the extrusion die and check your machine settings against your data sheets. Example of a twin platen position at the top of the stroke. Once they are set up by the OEM, those standards should never ever change. Do not adjust the individual carriage height positions. Cutting sleeve wear and tear. Well, this is a really busy one. So rather than changing a cutting sleeve, a lot of people will just go and make adjustments to the height. Now this just introduces more wear and tear on the top of the machine, puts a lot more load on the mould. Parison support air. There are a number of critical parameters for this process, even more so on multiple Parisons. They include the air supply pressure, low air pressure regulators and flow control valves for continuous air, high pressure regulator and flow control valves for timed air. They must be recorded accurately on your setup sheet. Then the big one, regrind versus virgin material blends. Changes in the percentages will actually change the characteristics of your Parison. So once you have calculated the correct nominal regrind rate, set very strict min-max levels and keep them tightly controlled. So let's talk about indicators to tell you whether your setup is correct or not. A classic is, of course, regular compensatory adjustments. They'll be made to find the operating conditions, just so you can keep your machine running. A poorly designed extrusion tooling. That's another really good example of how things can go wrong. If you don't have the components all correct, then you'll create adjustment dependence to keep the production running. Faulty gauges. Well, they speak for themselves. They will destroy your results and should be replaced on a regular basis. Incorrectly set positions like the extruder position. If this is off-center by only a few millimeters, then it will give the appearance that the Parison support air needs to be tweaked, or the Parison needs to be adjusted. Record the extruder position very, very accurately. Contaminates building up on the extrusion die. Well, they'll see the Parison swing and vary in small amounts. Many technicians will adjust the support air to compensate rather than cleaning the extrusion die. It's much easier to do than stopping the machine. But once the extrusion die is cleaned, then the support air will be incorrect and then it'll have to be set again. Locking away controls and only allowing technicians to do basic cleaning during production runs will actually save you a ton of trouble over a long period of time. Okay, so how do you know when you have the right setup conditions? Well, when you dial in all your parameters from your data sheet and you start the machine, and the only adjustments you need to make is adjust the straightness of the Parison and then fine tune the weights, then you know you're on the money. So keeping a tight control on all the variables and non-variables and recording them, and if you can dial them in at the beginning of a mold change, then you know you've got it right. So in summary, any adjustments anywhere on the machine that are made must be measured and recorded on data sheets. Setting adjustments in place before turning the extruder on will not only save you a lot of time, but it will actually save you a lot of resin because you're not tweaking the machine whilst the extruder is running. Once your setup is in place, there should be next to no adjustments. All indicators should be cross-referenced and confirmed as good or bad before any changes are approved prior to being made. Okay, so that's a wrap on Lesson 6, Variables and Non-Variables. Make sure you get them in control. So next Lesson 7, we're going to be covering off another one of my favourite topics, and that is the extrusion blow moulding machine Platen. And I'm going to uncover a few hidden secrets that many people don't know about the performance of your mould and its relationship to how well you look after your Platen. Oh yes, and of course, don't forget to look at my rules to live by and make sure you live by them. So until then, have fun blowing a bottle.